Don't look, I'm just shuffling. Every day I'm shuffling.
Alright.
Alright, done, I'm done.
Okay.
Alright, ready?
Alright, yep. Magic trick time.
If I've done this right,
yeah,
you cut it in half, you put it to the bottom, and this, at the top, is your card.
No, it's not my card.
Are you sure? 5 of diamonds?
Yeah, yeah.
Is this your card?
No.
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 Where's your card then?
Oh. This is my card.
Morrison Smiles. Told you to plug the card back in the deck.
Oh, evidence again.
We'll do it again.
Alright. So, we're on to binomial distribution.
And there was a French dude.
Yeah, he loved gambling and...
No, he wasn't one of those French dudes. He's not one of the Citroen Picasso designers.
Oh.
He was a very good mathematician.
Yep.
He did Pascal's triangle.
And
all of this stuff.
Yeah, he did stuff with binary stats. So he likes finding out things. We have two things you're talking about, two different probabilities.
So because he's French, you can either drink red wine or white wine at the end of the day.
Never rosé.
No one likes rosé. So that's what this whole chapter's about. Two possible outcomes. What's the probability that you hit one of them a certain amount of times?
Yeah, so simple example I think is a coin.
Yeah, that has two outcomes, head or tail.
Yeah, you can't have both. So we have a magical coin where it's fair on each side. And we're going to flip it 3 times, and we want 3 heads.
We're going to flip it 7 times, not 3 times.
My bad.
Yes. And we want 3 heads. So we could get the 3 heads straight away, just get head, head and head. And then tail, 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 tail. You should be taught while I write all of these out.
So what Wayne's doing is writing the combinations. He's doing something you should never do in an exam, is writing all of them out by hand. There's a quick way to do this, isn't there, Wayne?
There is. I should probably do that.
We should. So there's a magical button in your calculator called the NCR button, where the C stands for the combinations.
Yep. N is the number of times you do the thing, which in this case is 7, and R is the number of times you want that thing to happen.
Yep. And it will tell you the amount of times, out of ways this can happen. So
7C3.
You can put this in your calculator. In a graphical calculator, do a bit of looking to find it. Scientific, it's just a button.
Yes, so if you have a graphic, well you should have a graphic for this exam for the special stuff later, yeah. But I would advise you get familiar with where it is now, so you can do it quickly. And that equals 35. That means there's 35 of these combinations, so there would have been 35 lines.
That took a long time, and you might have not got it right.
Yeah, so very unwise to do that.
Okay, so now we have the amount of combinations, and we've decided it's a magical fair coin. There's a probability of half of getting each one, but now we need to find out the probability of getting our 3 heads. So, probability of getting a head is half.
Yeah. And in stats, an and means times. So you're getting a head and a head and a head. So it's a half times a half times a half.
Which is the same as a half to 3.
And you times that by the probability of the rest, which in this case is still a half.
Yep.
There's a half and a half and a half and a half.
And then again, that's at a 4. So then you just do this and just give you the probability of getting 3 heads in 7 flips.
Yes, this simplifies down to a half to the 7.
But this will only happen if your probabilities are the same, and they're often not quite as nice.
No, but in this case it is. And you times it by 35 because this is just the probability of 1 row.
Yep.
Which gives us the probability of 35 times 0.5 to the 7 is 0.27.
Alright. Yeah. And you can sort of logic out why I've done each step, and you could, I guess, work it out in the exam, but there is a formula, and it speaks about a few snazzy things.
Yes. So Triv writes this up.
So, it mentions stuff about parameters.
Yeah. X equals X, like that.
If we're in the top corner, so what's the parameter, Wayne?
Well, it's displayed like this in exams. You've got P, a little squiggle X, and then NP. Parameters are the NP part. And the parameters are the thing that it's within, so N would be 7 in this case. N is the number of times you do the thing, and P is the probability of the thing you're looking for, in this case, a half. Yeah. So your parameters here would be 7, a half, like that.
Yeah, and what we basically did right now is use this. So if we put in our numbers and write it like a chart, I think.
Yeah.
Okay, so as Wayne said already, n equals 7.
That's the number of times we're doing it.
Yeah. Our p will equal a half.
So that's the probability of the thing we're observing.
This is the same as the NCR thing, and x being the amount of times you want to get our thing.
Yes, so the x in this case would be r in our NCR button, and it's 3. And then we've got all of the numbers.
Yeah, you just put it in. So you know it was 35 times probability of our thing, the amount of times you want it to happen,
Which was 3.
then times probability of the difference. Now in our example, it was the same,
Yes.
but it's not always, and this is where this comes a little bit more handy, and the difference between n and x.
So I think the best way to explain what this means, as opposed to talking about this example, is to do another example.
Alright.
So
So
I'll
let's
drop
do
all
that.
of this off, but keep the top formula there, because that'll be useful.
Alright, so I need another example of 2 outcomes. Have you had your tea today, Wayne?
I haven't yet. I'll see have my tea in a bit, actually.
Oh no.
Oh, but that means I'm more likely to get angry and all stressed and frustrated and punch you in the face.
It does mean that.
You're smiling now.
So, if Wayne hasn't had his tea, the probability is 1.
Yes, I will definitely punch you in the face.
But let's say he's had his tea.
Yes. And if I have, the probability of me getting angry is decreased, but if it's only 1 tea, it's still about 0.6.
Not 0.6.
And that's the probability that I will punch you in the face.
Yeah, so if we do the 10 chapters, so that's 10 videos. So if we do 10 videos,
That means our n is going to be 10. The probability each time we film each day, each of these 10, is 0.6.
yeah.
Let's
So-
find the probability that I punch you on only one of these whole stats videos. Just the one.
Okay, so
X in
x
this
is case is 1. Now if there's a chance of something happening, there's a chance of it not happening, so that's the difference. The probability of him not punching me in the face is 0.4.
It is. So let's go ahead and actually work out the probability that in all 10 of the stats videos on YouTube, I only punch him once in them.
Alright, so let's put our numbers in. So using our parameter sign like they do in the exam.
Yes, the parameters here, probability x, and then n, 10, b, 0.6, just to write it out in expressed forms.
Yep. Now we can just put our numbers in. So NCR, in this case, it will be 10C1. Now that's just 10. There's a few you get to remember after doing this a few times. Then we have a probability of it happening,
Which is 0.6.
so there's a 1, so we don't need to write that there.
Let's just type in 0.6.
Then times the difference, which is 0.4,
This is where the formula is more useful.
times the amount of times it could not happen, which is 9.
I don't know what that is.
I don't know what that is either.
So, just ignore that I did that because I don't know what the next bit is. I'll put equals. Are you ready? This is
Yep.
the probability that I punch you just the once in all of the stats videos on YouTube.
Okay.
6 times 0.4 to the 9. You're in luck, Triv. 1.57 times 10 to the minus 3.
That's quite low.
It is quite low.
So sometimes in stats they like to show stuff graphically. So we could do this and work out how the chances of him punching me in the face 2 times, 2 videos, in 3 videos, in 4 videos, in 5 videos, and it always follows a similar pattern.
And this goes all the way up to 10.
Always up to 10, yeah.
Because that's our n. And
That's
actually,
our
it's actually 0, that is a value. I could punch him none of the times.
You could. And then each one will have a certain probability, and it always follows a shape, doesn't it?
It does, it will follow sort of this kind of shape.
Yeah, the stakes will get steadily larger in the middle, they'll be the highest.
So there's the most chance I punch him 5 times. But this is fine, this is the 5th chapter. So that's unlikely now, based on how many we've got left.
Yeah, you might just punch me in every video.
I might, but that's unlikely, isn't it? The last chapter's quite friendly. I don't think
I think that'll be fine.
I'll just make sure I get tea.
Okay, so yeah, there's something I like to do this, but I'll just mention it so you don't go.
They like to express this in tables as opposed to an outright question like this.
I do like tables. I've got a table over there. You can use that, right? Oh, get him tea. Get him tea.
Chances of that happening.
So, got some tea.
Actually got more like 12.
Yeah, and now Wayne's much more chilled out. Put him in the freezer for a bit. And I shouldn't be punched in the face.
As long as you don't say anything more stupid about tables.
So, get these teas down. Before, we went through getting the probability of getting a thing, or not getting a thing, but that's not always that useful.
No, for example, in businesses, rather than saying what's the probability of doing this 4 times, it's 4 or more times, or 4 or less times.
Or like working out warranties, how many times will it do it before it breaks? Will it be this times? You're going to be less than, you want to find out when it is.
You don't want a hairdryer to break in first use, so you'd want to know what's the probability of it dying in under 200, and if it's a high probability, you probably should improve that hairdryer.
Probably should improve the hairdryer, yeah. So, got an example of this sort of question.
Yep. Exam boards seem to like fairground games.
Yeah, I think they're all a bit gamblers, so...
Like the French.
Like the French.
So you got a 6... You got an 8-sided dice.
Got an octahedral dice, which is
6
8-sided
sides of it is red.
Yeah, 6 sides of this dice is red, so because it's binomial, it means two of the other sides are one colour.
And that's white.
Never white.
And the question says you roll this fair dice. It says fair in the question.
Okay. 10 times. So now we know Rn.
Now, rather than just being a set value, it's what we were just talking about, find the probability that you get at least 4 reds.
So, to do this you need to use ideas about cumulative probability, adding probabilities up. So, I think I have an idea of how it might work.
Yeah?
Yeah. What I'm going to do is I'm going to work out probability of getting no reds, then 1 red, then 2 red, then 3 red, then 4 red. Right. So,
Okay.
NCR.
But while he's being a melon, there's an easy way of doing it. And what I've wrote here is you've got the probability that you get at least 4 reds. R is red, and it's greater than or equal to, and the probability of that. Because you want more than 4 reds. But the probability of getting a red in each individual roll is 6 over 8, which is 3 over 4, which is 0.75. However, in the tables we're just about to go through, math error, you missed like 4 brackets there.
Oh yeah.
And that's not a minus. And you put a sign in there for no reason.
It might have been a circle.
I think you should just go the real way, to be honest.
I think we should just do the tables, yeah.
Much easier than that.
Okay, so the tables we're about to go through only go up to 0.5.
Whereas the probability of getting a red in each individual roll, not all 10, is above 0.5. So we actually go with the white one.
Yeah, so we go, instead of using, because the difference will have to be 0.25, and then we have to use a different inequality sign.
As opposed to at least 4 reds, so 4 or more reds. The way of saying that is 6 or less whites.
Yeah, because that's the other way of happening with 10 rolls.
You want less than or equal to 6. You
Yeah.
can have 6 because it's at least red, not 4 or more.
Yep.
So less than or equal to 6. And that's where this table comes in.
It does, so maybe we should look at the table.
Yep. The table we are looking at is on page 16. The tables actually start the page before on 15.
But our N is equal to 10, so we have to find that table.
I think another good step to start with would be to put up our parameters. So as Triv just said,
That's a good plan.
N is 10, the P is 0.25 because that one is too high, so we have to go the other way.
Yep, so then you can see the parameters on the thing, P being the thing at the top,
Yep.
N being the section you're looking at, and then X is our number.
And in this case, because we want it to be 6 or less, and what the probability gives for each value of X is that or less. So, you go to N equals 10, you go across the probability of 0.25, then you go down to 6 across the X, because you want 6 or less, and that gives you the probability. It's done it, it's got your answer.
That's pretty swish. The only difficulty is working out what columns everything is in.
Yeah, which standing up is much harder than the exam. In the exam I would advise you get a ruler, or line up your pencil along the lines and find the exact value.
I think it's that one.
0.9965, and it just gives you that as that.
So that's pretty handy, and that's a lot quicker than doing what I was suggesting.
Yeah, a lot of errors are in there. I think you should work more on that.
Okay, sorry.
I don't mean to be mean.
That's what we're on to next.
Yeah.
So, using these things, we can make a table.
Yes.
Like we mentioned before, they had a graph where we could work out each thing individually.
Yes, you've got X across the top and the probability of X on the bottom. So
So the probability of being punched in the face 0
Not
times, then 1 time, then 2 times, 3 times. We'll just go up to, well, just 3 is fine. And then
if I dot the die, would go up to 10 in the actual thing.
it would, and we'd have worked out the probabilities of each of these happening, so we could just make these up. We knew what one of them was.
Yeah, I don't know what it was.
I don't know what it was.
We'll just make up some values.
Well, let's make up some values.
So that's 0.05, that's
Okay.
0.1, that's 0.15, that's 0.2. And it would go on and on, but basically
and these would end up adding up to 1 if you did the full thing.
And we're doing the individual ones, not the less than. So this is what we did just a minute ago when I worked out the probability of punching Triv in the face.
Yes. So, first thing we should do the mean. Can work out a few things.
The mean of this, mu, is equal to NP. And N and P simply give parameters.
Yeah, that's pretty friendly.
N in this case is 10, because there was 10 videos we're filming, 10 times we're doing it. And I said the probability of punching Triv in the face each time was 0.6.
So, that's just 6.
Yeah. The mean is 6, so that means that across this table, 6
Really
would be about there.
Yeah, the most
And
common
that would be-
amount of times he punches me in the face.
Yeah.
So then we can also work out the variance.
Yes.
I remember the variance is like the sigma squared.
And it's NP 1 minus P, like that.
Okay. So, again we're going to put our numbers in.
That's 10 times 0.6 times 0.4 in this case, which is 6 times 0.4, which is...
I think you should use a calculator
Think
just
we
to
should.
remove any error that we might have in our mental maths. You do have a calculator exam, so you shouldn't need to do anything you don't need to do. It's 0.24
I would not have got that. And then
times 10.
times 10.
I didn't do the end bit.
I've done times 10, the 6 times 0.4 is times 10.
Oh yeah.
So then the square root of that gives you your standard deviation.
But I didn't write down 6. So that's 2.4.
Bloody hell, you need. And the square root of that?
Yep. Which is, and Wayne's calculator is a strange place, 1.55. So that would be very rare to remembering as on that standard deviation is a measure of spread.
So now we should go on to a test yourself, which uses some of this, because we haven't done a worked example, and hopefully some of the other stuff, we'll see what we can find.
Alright, let's do that. So we got a question.
Yep. Test yourself, page 75, question 2 from this book.
And that ages.
I know, we've been filming like physics or something.
Yeah, right. So, question says, a specialist bicycle shop builds made-to-measure bicycle frames. The shop has 40 orders for frames. Past experience shows that the probability of a customer who has ordered a frame failing to complete the purchase is 0.04 and is independent for each customer.
Right.
Part A says, find the probability that of the 40 orders, the number of purchases not completed is 4 or fewer. This is part 1.
So not completed is 4 or fewer.
Yep, and part 2 is exactly 2. So we should do that bit first.
Okay, so that's the probability that they don't get bored, is that right?
Yep, and so that's our P,
Okay.
this is our N.
So I would do that, as I said before, the probability of it.
Yeah, right, your parameters out.
M, P.
Okay, and the first question is like the one we just did.
Yeah, so it's less than 4, is that right?
Yes, yes it is.
So
Yes, 4 or fewer. So it's equal to as well.
So this one's just a table question.
It does just work in a table.
And N
Except
is 40.
N is 40, so that's
way
quite far on.
It's there.
Alright, so
So we're at the N is 40 box like this. P is
Yep.
0.04, which is there.
Yep.
And we want 4 or fewer, so we go
Yep.
0, 1, 2, 3, 4. You ready?
Yep.
0.9790.
0.97.
9790. And I would quote as many figures as you've got here in your exam because you've got
Yeah.
them.
It's not like there's an accuracy reading to think about. It's maths.
This
So-
one's exactly 2. This one's a
Yeah,
maths.
so that means we don't use the table, we use our formula.
Yes.
So I'll quickly write up a formula.
Okay. So we've got the NCR where N is 40 and the r you want exactly 2. Then that's going to be times by this probability squared times the rest of the probability to the 38, which seems bizarre, but that is right.
So, our MCR, once again,
Okay, I'll do it, ready?
is
40C2.
Alright, which is,
780.
that's quite a lot.
Yes, because this number's really small, that's quite
That's alright. So then we have our probability, which is 0.04.
That's times by 0.04, and that's squared.
Yep. Then times the difference between 1 and that, which is quite a lot. 0.96.
And that's to the 38.
Okay. And what does that give us, Win?
Bear with.
Alright.
0.265. Which is a reasonable answer.
That's a reasonable
It's
answer.
terrifying to say that to the 38. That looks wrong,
Yeah.
but it's not.
It's not, that's fine.
Okay,
Yeah.
there's a part B.
There is a part B.
Alright. But notice we're writing entirely in colour.
Yeah.
The black's running out over here.
Yeah, and we're running out of pens. The new building we've gone to at school, everything's interactive, so they have no ink pens left, so our supply is dwindling.
Not that we nicked these pens from school.
No, we didn't. We're like a charity of learning. So part B says, find the probability that the purchase is completed for all 40 orders. So, yeah, it means it's completed for every single one. So probability it's completed is 0.96. Because that's what it is, not completed.
Yes, sorry, it took me a second. And so it's completed for all 40.
Yep.
So 40C40, is that 40 or is that 1? That's 1. I'm sorry. 40C40 is 1.
I think we should check that, but yes.
Right, I'll do it. You ready?
Yep.
40C40 is 1.
Yeah, okay. Times probability, which is 0.96.
0.96 to the 40.
And the other thing to the 0 would just be 1, so you need to put that in.
Yep. Which gives us, it's basically just 0.96 to the 40, and it's 0.195.
And that's the question. And this is sort of what a lot of the questions are like. Again, it's from an exam paper to try to do.
Yeah, which exam paper is it, Triv?
It is 2002.
Yep.
All the ones in this book are from the old specs, but it didn't change that much.
No, so this sort of question
This
still
sort of question
comes up.
does come up. You just have to remember what the formula means and when to use the table and when not to use the table.
Yep. So that's that. Let's go on to the summary.
That's a summary. Summary time.
Binomial distribution.
Sounds really evil, but it's not actually that bad.
It's not. It's when there's two possible outcomes and you want to know the probability of stuff happening to the stuff with the things.
It's pretty much just that. You got to remember what your things are in your equation. So n.
There's a number of times you do it.
Yep. X is the thing you're paying attention to.
Yep.
What else is there? P
is the probability
of
of
it
that
happening.
happening.
And then understanding what the parameters thing means. Something that don't say these are parameters, they just give you the weird P, strange thing, X, and then numbers.
Yes, and you have to remember
That the first one is
N,
N,
and
the
the
second one is P. Yeah,
It's not that hard, it's actually
Not
fairly
hard.
easy marks, the entire thing.
it's often quite mark heavy as well.
Yes. The tables are often quite mark heavy in particular.
Yes, because you have to realise the less than. Sometimes you have to use the other one because it's higher than 0.5.
Yeah, and
And
the table only
that
goes up to
sort of thing.
0.5 as probability across the top. So
Yep.
change that.
You change
And
that.
then you have to do everything opposite to what it was.
Yeah. That's that.
That is pretty much that. Remember the formulas.
Yeah. Did you get the Mario figure the formula?
Not that I know of. Maybe. I
Maybe.
haven't looked extensively. I don't think.
I
you
find it
do.
easy to remember the things in the book because unless you on your head what page they are, I think it panics you if you have to look for something and if you can't find it.
I would just remember these.
I
I'm
just
not
remember
convinced they're in the book at all. Mean is NP.
Oh yes, and the variance is
NP bracket 1 minus P.
P. Yeah,
And then standard deviation is the square root of that. And you might just be asked to do that.
that's
Few
okay.
marks.
For nice marks, and you might, it's not very likely, be asked to draw the table or interpret the table
Yes.
into a graph.
Interpret is much more likely than draw.
Yeah. And then you put it into a graph, then you go to work out things from it.
Yeah.
So,
that's that,
bad
really.
binary distribution.
Yeah. We'll see you at normal distributions in the next chapter.
We will. Let's crack on with that.
Yeah, chances of me punching you there aren't very